So let's look at one where we have more than one transformation at a time. So this is h of x is negative square root of x minus 1. Okay, so my base function of the 4 that I have to choose from in the library functions, I've got the x squared, x cubed, square root, and absolute value. This obviously is going to be the base of square root of x. So that means it looks something like this, right? Starts at 0, 0, and goes to infinity on the other side. Okay. For shifts, I'm looking for adding and subtracting. So this one, I add or subtract, so I do have a shift. Is it inside or outside of my square root? Well, it's inside of my square root, and that means that I'm changing x's, so it's a horizontal. So I shift by 1. Since I'm subtracting, horizontal is the opposite, so I'm actually going to move to the right 1. I don't add or subtract anything else, so no vertical shift. Stretches, I'm looking for multiplications by non-negatives. I don't have that here, so no stretches. And reflections, I'm looking for negatives. So I actually do have this negative out here in front. So is that inside or outside of my square root? It's outside because it's not underneath of the square root. So that means it's outside, changes y values. So I'm going to go from positive y values to negative y values. So that means I'm going to reflect over the x-axis. All right, and that's it. So let's do it graphically. Let's actually do the points and then we will do it graphically. So I'm first going to list the points algebraically, and then I'm going to do the graph. Okay. So my anchor is the square root of x. Remember that the anchor points are just any 3 points you want to start with. I have given you guys the 3 easiest. Order of operations says that I need to do my horizontal shift and then my reflection. So I'm going to do my horizontal shift to the right 1. And then I'm going to reflect over x axis. Okay, so my anchor points are 0, 0, 1, 1, and 4, 2. Horizontal shift. So if it's horizontal, I'm changing x's. If I want to shift to the right, I need to add 1, right? So add 1 to x, y stays the same. Add 1 to x, y stays the same. Add 1 to x, y stays the same. Reflect over x-axis. So here's me doing one of the transformations. Now I'm going to take these points and do my reflection. So I'm doing them sequentially. So if I reflect over the x-axis, this reflection was a negative on the outside. So x stays the same, y becomes negative. 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 So if you do this table technique, you can just graph these 3 points and you're done. You don't have to do each individual step on your graph as long as you have this table done. I'm going to be looking for something that indicates you applied the transformations in the correct order. All right, so you can just graph the final result. I'm going to graph it step by step as if I did not do my table. Now we know what our result should be, right? So this is my result. Okay. All right, so suppose I didn't do the table and I'm just doing graphically. So first step is shift right 1. So I pick up each point and I move it to the right 1. 1, 1, 1. So this is x minus 1, square root. Then I'm going to imagine that I put a mirror here on the x-axis and reflect, because that's going to turn positive-wise to negative-wise. So this point is on the mirror, so it doesn't move. This point moves right here, that's equidistant, and then this point would move down here. Totally missed that point, but that's okay. So that's negative square root of x minus 1. So blue is your answer. 1, 0, which I have. 2, negative 1. 5, negative 3. So whether I graph each step or do the table and apply transformations to the point themselves and then just graph the result, I still get the same answer.